This is your unit review for Unit 6, all worked out. I'm going to explain all the work. If you need to pause as I explain, feel free and check your answers. So SOL 8.9 is to verify and apply the Pythagorean theorem. So this is the first couple of questions. Number one, we're finding the missing length of the triangle. We're looking for this right here, which is our hypotenuse. So from A to B, that is our C value. Remember that the 4 inches here and the 7 inches here, it could be A as I've got it and B, or it could be, this could be B and this could be A. It doesn't matter which way it is. But the only thing that does matter is your hypotenuse must be C. Remember, ladies and gentlemen, please start with a formula always, and then plug in the numbers. So whatever you assigned for A, I did 4 for A, I did 7 for B, and of course C is the same. Make sure you square it. So we have 16 plus 49, and the C squared stays the same. Remember, when you're adding it up, ladies and gentlemen, you're adding this up here, and you're putting the answer right below it. You're still having C squared equals C squared down here. This was an equal sign there. And then, remember, because it's C squared, I cannot have that as my answer. I can't say that 65 is equal to C squared. I have to find the square root of both. This part cancels it out, so I'm left with a C all by itself. And the square root of 65 was 8.06 something or another. And it tells me in my answer up here, or excuse me, in my directions, it tells me to round my answer to the nearest whole number. That means this place right here, and that means my answer is C is equal to 8 inches. Please make sure that you do have a proper unit with things. On this one here, it says to select all the triangles whose lengths prove that they are right triangles. You must select all that apply. Remember, they're going to have you click on all that apply, or circle all that apply, or possibly drag and drop on an actual SOL. But here we're just circling. The key thing is when I'm given 3 different measurements or 3 different numbers, my C must always be the longest measurement. It's always the longest measurement. So I've got my formula up here that I'm going to use for every one of these. And again, I've kind of labeled, you'll see on A, B, C, D, and E, I've labeled on top A, B, and C. Again, A and B are interchangeable. You can change that if you need to, but the longest side has to be the C side. All right. So then I went ahead and just squared each number as I did it. So I said 7 squared was 49, 6 squared was 36. When I added those up, I said that 85 was equal to 100. I'm sorry, and the 10 squared was 100. And that's clearly not true, so therefore that gets marked off. All the rest of them, B, C, D, and E, they all work. So when you do the math, again, this here is the 0.3 becomes 0.09, the 0.4 became 0.16, and the 0.5 became 0.25. And when you add that up, the 0.25 does indeed equal 0.25. So that's how you're doing it. You're making sure that the answers work. Again, this is a 3, 4, 5 triangle. Remember, I did mention about 3, 4, 5 triangles. If you can remember that, you already automatically know it's a right triangle. However, we can do 3 times 3 is 9, 4 times 4 is 16, and when I add that up, I get 25. So you're just doing that whenever you're solving a question like this. Number 3, we have a problem here with a picture. It says a wooden board that is 12 feet long is leaning against a wall perpendicular to the ground. What they're saying is that the wall here, there's the wall, it's perpendicular to the ground here. So there's my right angle there, which makes the triangle part the right angle as well. The point at which the wooden board touches the wall is 10 feet above the base, excuse me, is 10 feet above the ground. How far away is the base of the board? So we're looking for this part right in here. And I don't think my colors are going to change. Oh, they did. Okay, good. So there we go. We're looking for that part right there. So again, we have an A. I had A is 10. I had B was my X, or my unknown value. And this, remember, my board, this is the board part right here. That's being leaned up against the wall. That's my C value. That's my hypotenuse. So keep in mind, too, as you're solving, whatever you get for B, or if you interchanged it and you said A, either way, it has to be less than 12. It has to be, because 12 is the longest it can be. I mean, the longest measurement of my triangle. Again, plug in your numbers and then solve. And remember, when you get down to this part here, This is where it gets just a little different than what we did in number 1, because I need to get b squared alone, which means I'm going to get rid of the 100 by minusing 100 here and minusing 100 over here on the right side. And I get b squared is equal to 44, and then the square root of both, and then I get that answer. But again, the original directions actually told me to round to the nearest tenth, so I'm rounding to this place right here, and so here is my final answer. B is equal to 6.6 feet. Number 4, this is one I've seen before on different kinds of problems that I've seen, SOL released items, that type of stuff. And it says, for the rectangle shown, which equation can be used to find the value of x? And choose all correct answers. Now, we are used to this right here that we've been saying. We've been living right here. A squared plus b squared equals c squared. But that also means that if I am given the c squared, I can subtract the a squared, and that would give me the b squared. Or I could do the c squared minus the b squared, and that would give me the a squared. So we have a couple of different ways that we can do this, and we have to be thinking about it. So the best thing I can tell you is to actually do the math and figure it out, and then if you can't remember the different rules here, and then make sure which choices, A, B, C, D, E, F, G, which ones match up. But one of the things I know is this is not correct. I'm not squaring after I add the 7 and the x. That does not work, so that one's out. 7 squared plus x squared, that's what we're saying. A squared plus b squared, there's my a squared plus b squared, equals the c squared there. And so that one works. C is like my example, the second one I did, or either one really, depending on how you've labeled it. So here we have 15 squared, that's my c, minus the 7 squared, which was the a, is going to give me the b of the x squared. So again, that works. This one here on D doesn't work because neither one of these are squared. The 7 and the 15, neither one are squared. On E, we have 7 squared minus 15 squared. Well, automatically, I know that's going to give me a negative number. I can't have a negative number for a measurement, so that's out. But also, that would be like saying the a squared minus the c squared, and that's not true, is equal to the b squared here, and that wouldn't work. F does work because you've got the 15 squared minus whatever you want to call it, a or b, is going to equal the 7. So you're minusing the x squared equals the 7 squared, and that's true. Again, on G, we have, you can't subtract them to get the answer. If you're getting the c squared, this has to be an addition sign there, so that's wrong. Number 5. Number 5 says to find the hypotenuse of a triangle with a base of 11 centimeters and a height of 9 centimeters. If they don't give you a picture, ladies and gentlemen, draw a picture. Makes your life a lot easier. Draw a picture. We already said base and height. So there's the base here. There's the height here. If you wanted, and I actually did sort of use the base as 11, and then the height I used as the A for 9. This then is my C, and that's what I'm trying to find. I'm trying to find that hypotenuse. It even tells me I'm finding the hypotenuse. So we have our formula, we plug in our numbers, and we solve. The same thing we've been doing. Number 6 is a little tricky. I need to have a picture here, and my picture is a mess, so I'll try to clean it up as we're working on it, okay? So first of all, it says that Scott wants to swim across a river that is 400 meters wide. I'm going to go ahead and draw the river again. This is my picture here. This is what I did for my picture, but I'm going to kind of draw it again here. So if we're drawing, if this is a river, here's the river here, and we already know that the width of the river was 400 meters. So from here to here, this is 400 meters. Okay, so again, we're drawing a picture, making sure we're okay with what we're doing there. Now it says that he begins swimming perpendicular to the shore that he started from, but he ends up 100 meters down the river from where he started because of the current. So the current, what I was trying to draw in the picture was that the current, and I'll draw it on the outside of the river. So the river's in the middle, right? But I'm going to draw it here. So the current is doing this, is dragging him up here as he's trying to swim horizontal, or excuse me, perpendicular this way. So since it's doing that, if he starts here, he's going to wind up down shore, like let's say there. So this is actually the way he wound up swimming. But you can tell it made a right triangle basically. And so again, we're going to use our Pythagorean theorem to help us solve. So the question says, how far did he actually swim from his starting point? All right, so we know this. We know that was 400. on the width of the river. We also know that he landed 100 meters down downstream or down the shore. And so we're trying to find that red dotted diagonal line. So when you do the math, you've got a squared, which is going to be either 400 or 100, plus b squared equals c squared. And when you do the math, you get 412.310 equals c. But again, we've got to round it to the nearest tenth, because that was what the original directions told us to do. So this is our final answer here. He swam 412.3 meters. Okay, here's similar question. Well, not really. It's a question just asking about verifying your Pythagorean theorem. So when you're looking at this, and I'm sorry if it doesn't look like an actual square on my screen, it should, but I know on your paper it does. So it says Alex is verifying the Pythagorean theorem by using the diagram below. And we know that if, again, we're talking about the square here that's off of this side, that's a square, and that's A, so this is a 4 by 4. So there's 16 spots in there. That's a 4 by 4 square. This B is a 3 by 3 square, and that's 9. And then that means that C is a 5 by 5 square. And again, that is a square. I know it doesn't look like it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 times 5 is 25. So this is our proof of, showing a proof of the Pythagorean theorem. So we have to read the statements to see if which one best describes the picture there that actually shows the proof. So in A it says the length of side A plus the length of side B is equal to the length of side C. That's not true, because if I had 4 plus 3, I don't get 5. And my length of that side here was 5. This one is 5 on this one, 5 by 5. Okay, so this, and again, I should try to write that a little bit. This is 5 here, and then it was 3 on the bottom. That side there is 3, and I'm sorry, my pen is a little wide, and then this is 4. Okay, so when I draw the triangle at it, it's a 3, 4, 5 triangle. But as now B says, the perimeter of the square A and the perimeter of square B is equal to the perimeter of square C. We've never said anything about that, plus that doesn't work. When we look at C, it says that area of square A plus the area of square B is equal to the area of square C. And that's what we're talking about, because it's the whole area there. That area of 3 by 3 is 9. The area of 4 by 4 is 16. And 16 plus 9 is 25. So C is the correct answer. And again, we're not subtracting. D was telling you to subtract it. Number 8, we're asking which cannot be classified as a right triangle. So we're looking for the one that is not. And these triangles are not drawn to scale. Remember that we talked about that too, that in geometry they don't necessarily draw things to scale. So although they might look like a right triangle, they may or may not be a right triangle. For example, A looks like a right triangle to me, but it is a right triangle. When I do the math, again, it's a 3, 4, 5 triangle. When I do the math, it works. B also kind of looks like a right triangle. It kind of looks like this right here is a right angle, but I can't go on what it looks like. I have to do the math. But the measurements do tell me when I do the math, it is a right triangle. C doesn't look like a right triangle at all. In fact, it almost looks like it's isosceles or equilateral. But when I do the math on it, it is a right triangle. Those numbers there, 4, 4.2, and 5.8, do make a right triangle. Remember, this has to be C, because C always has to be the longest side. The one that does not work is D. When I do the math here, and this actually looks like a right triangle, but it is not based on the numbers that we have. This one would be A or B. This would be A or B. This one has to be C. Because that would be the hypotenuse, especially the way that was drawn. But also, again, the largest number would always be the hypotenuse. Okay, now we're talking about using angle relationships, so make sure that you're remembering those words. Remember, we have words supplementary, complementary. Those talk about the measurements together equaling 90 or 180. They cannot be both. If you check that it's supplementary, it cannot be complementary. So right here, that's exactly what we're talking about. It says if QRS and, angle QRS and angle SRT are supplementary, you can see I wrote up here, equals 180 degrees, and the measure of angle QRS is 42 degrees, what is the measure of angle SRT? Well, all I need to do is take 180, that's my supplementary amount right there, subtract the 42, and I get 138. If you want to do it algebraically, then what I would do is I would literally say that the measure of angle, I should have written the M, the measure of angle QRS plus the measure of angle SRT is equal to 180 degrees. And then I plug in what I know. The QRS was 42, SRT is X, and 180 stays 180. I'm going to subtract 42 from both sides, and then I'm going to wind up with X equaling 138 degrees still. Either way, you can do it with algebra, or you can just do the 180 minus the number you know. Number 10 is talking about our complementary angles. It says which one is complementary to angle 1. So I circled angle 1. I'm looking there at angle 5 because angle 4 shows me my right angle there. And I know then that this together, both of these together, is going to equal a right angle. So those two together, if I add them up, it's going to be 90 degrees. So, but all I needed to do was the adjacent angle, which also made it the complementary angle in that case. Not all adjacent angles are complementary. Number 11, remember it says to select all the pairs of adjacent angles. So, and it says must select all correct answers. What I did is I looked at all my choices. Now, A said angle 2 and angle 3. So I looked at angle 2 and angle 3, and they clearly are right next to each other, right here. 2 and 3, they're sharing that ray right there. So therefore, yes, and I circled those. 5 and 3, 5 was here and 3 was over here. They have no relationship. They're not opposite, even though they're kind of on the, they look like maybe, but they don't quite make that bow tie thing. So they're not actually opposite. C, 1 and 4, those are vertical because this is 1 and this is 4. That does make my little bow tie thing that we were talking about. There's my bow tie on that one. And then the rest of them, D, E, and F, they are all adjacent to each other. 5 and 6, you can see they share this ray right here between. 6 and 1 is right here, that shares this one. And then 5 and 4 shares this right here. So all the rest of them were adjacent. And again, adjacent means next to. All right, on number 12, below is a pizza cut into equal slices. What is the angle relationship between pizza slice A and pizza slice C? So you can see that I circled those. This was A, and this was C. And again, if I make that big X with just this part here, it does make the big X, and that makes my bow tie right there. So those are vertical or opposite. Remember, if you think of them being opposite, just remember the other word, the mathematical word is vertical. All right, number 13 here, we have finding the missing measurement. Now, a little bit of work happens on this one because we're trying to find the missing measurement for angle 6. So we're trying to find this one right here. And I'm given the measure of angle 2 right here is 28. So I like to write it right in. So I wrote it right in there. There's angle 2, and that was 28. The measure of angle 1 they don't give me, but they do give it to me because I know that this right here means that it's a 90-degree angle. So right there, boom, I have 90 degrees. And now I know that all 3 of these together, I'm not looking at the other side. This side over here, I'm not looking at that at all. I'm looking at everything to the right and up, I should say, angle 6, 1, and 2. That's all I'm looking at. I'm not bothering with anything else. But I can tell that they're on a straight line, which means altogether, angle 1, angle 2, plus angle 6 is going to give me 180 degrees, which I wrote right there. So then I'm plugging all my numbers, and I solve. All right, now we're talking about transformations of figures. On this first one, number 14, it says, what transformation best describes how this picture was created? Again, on your paper, you probably see it a little bit better, but it's kind of like birds that are facing each other, and then they're kind of against each other. So all they've done on this, basically, is a reflection on it. It's clearly not A. It's not a dilation. These shapes of the birds, like I said, they're sort of like a bird. They do not get bigger or smaller at all, so dilation is out. It's also not a translation because we're not just sliding it from one position to another, going up and right or down and left or anything like that, or even just straight up or straight down. They're clearly reflecting because you can see their beaks are touching at different places. So because they are, and there's actually a little bit of a rotation in there, but again, we're not worrying about that, plus that's not an answer choice. So based on our answer choices, reflection is the only correct answer on that one. Number 15, it says, which type of translation has occurred in the graph below? All right, so it says here, well, actually what I did is I looked. From A, I kind of know that I went right, and then I went down to go from A to A prime. Remember that this right here says A prime, and remember this is my pre-image here, and this is my image here. This is the image here. The new image is always the image. The pre-image is the one that you start with. So we have, what I know here is that the x moved to the right, because as I said right here, we saw that on my x-axis, this is x going right, left to right, but it was moving to the right, so the x was moving to the right. That's a positive move. I also know that my y value was moving down. If it's going down here, that's a negative value. So I know it's going to be x plus something and y minus something. I will say on my paper that this picture looked really small. It's blown up here on my screen. I was having trouble reading the numbers, so I know, but all I needed really to know is that this was positive, x was positive, and y was negative. This is both positive, so that's out. This is a negative and a positive, that's out, because we're not minusing from x, we're adding to x. Here we're adding to x, and we're minusing from y. That's what we want. And here we're minusing from both of them. We do not want that one. So even if you can't read the picture or the diagram, think logically. It didn't matter that I couldn't tell that it was right 4 and down 9. It mattered that I knew that I was going positive for x and negative for y. All right, number 10 here, it says triangle PLZ is shown on the grid below. And it says, what are the coordinates of L prime after L is translated 3 units horizontally and negative 8 units vertically? This is almost the same thing I just did a second ago. We know that we're adding 3 to the x because it's 3 units horizontally, meaning positive 3. So we're going 3 to the right. And the negative 8 vertically means it's going to be negative 8, meaning down 8, y minus 8. So if I wanted to, I could just take the point for L. This point here, it was negative 1, 3. I could have taken the negative 1, 3 and applied the math to it. So it would have been negative 1 plus 3. And then it would have been, I'm sorry, that was just the x value. And then it would have been 3 minus 8 for my y value. So this is x and this is y. And either way, this is what I wind up with here when I do that. Or I can just count. I can go over 3 to the right and 8 down, which is kind of how I did it right here. I did that. I went 3 to the right. I went 8 down. And then I got my L prime, and I counted what was that point there. It was 2, negative 4. Or negative 5, excuse me. All right, number 17, it says the vertices of a rectangle ABCD are as follows there. Plot the points on the graph for B prime after B is translated negative 6 units vertically. I'm not doing anything horizontal. All it is the y value is I'm subtracting 6. So my original B, I have right here, that was the original B. If I minus 6 just from the y value, I get 2, 1 for my point. And also, if I just move B down 6, I went down 1, 2, 3, 4, 5, 6. Then that became, right here, 2, 1. There's my points. So either way you did it, it can either do the actual math or just move the point and then find your new coordinate. It still works. But you can also have a way to check your work. Okay, on number 18 is talking about dilating. So automatically I wrote my note to myself, it's either bigger or smaller. It says it's a scale factor of 2. Well, a scale factor of 2 means I'm multiplying it by 2, so my shape is going to get bigger. If my shape is going to get bigger, it's going to look bigger than this right here that we have. So as we look at our choices, and the choices were a bit small when you're looking at your paper, A was the same. B was a translation where they slid it over, or up and over. C was dilation by half. They cut it in half. And so D is the only correct one where you're multiplying by 2. Every point, remember, would be, or every ordered pair would be multiplied by 2. So if I wanted to take each ordered pair for A, for B, for C, then I would just multiply each thing to get my new one. Number 19, it says if you reflect the image of triangle ABC over the y-axis, what will be the coordinates of C prime? And again, they really only want C prime. I didn't have to do the whole picture, but I did just to make sure that I didn't put anything in the wrong spot. So I know that A is going to basically stay in the same spot right here. B is further apart way here and here. And then C is further apart here and here. So when I do the math, or after I do that and I count my spaces, it was negative 4, 4. And I put it in here too. Number 20, it says draw the triangle A prime, B prime, C prime as the image of triangle ABC after it's been reflected across the x-axis and translated 2 units to the left and 3 units up. This is 2 separate things. So I know mine looks a little bit like a mess, so I'll do it in another color here as we do this. This is my original one is ABC. When I reflect it over the x-axis, this is my x-axis here that I highlighted in blue. Again, I just count. From B was however many spaces, I think it was 2 spaces away from the line. So my B prime is going to be 2 spaces away from the line. C was 4 spaces away from the line, so C prime is going to be the opposite way, 4 spaces away from the line. I'll draw another color. A was 2 spaces up, and now A prime is going to be 2 spaces down. Okay, so there's my first triangle. But now I also have to take that new one that I did and translate it 2 units to the left and 3 units up. So each point is going to go 2 spaces to the left and then 3 spaces, 1, 2, 3 up. And that's what we're doing. So this became the A prime right here. No, well, A prime again, really. This is A prime because I asked you to label it as A prime, B prime, C prime. I probably shouldn't have labeled it at all on this blue one I just drew. And then again, the B going to the left and then up lands here, and then the C lands here when I go left and up. So this is the final shape right here. This is what I should have on my paper. Over here, it's asking you to dilate by a scale factor of half. Okay, half means it's going to get smaller. And the way that works is I'm going to cut every single number in half. So they didn't give me any coordinates. I had to actually write them down. So these are all of my original coordinates right here. And so I listed them all. I just went and counted what Z or X, Y, wait a minute, did it all right? Yeah, W, X, Y, and Z. I did all those. And then I cut each one in half. So -4 divided by 2 is -2. And then 2 divided by 2 is 1. So this is my new point for W. And so it was -2, 1, which is right about there. I can't really tell that I did mark on here. And then the next one became 3, 1, 1, 2, 3, and 1. That was for X prime. And then Y was 3 to the right and 0. And Z was -2 and 0. So when I draw this out, it's right here. So this is my new shape right in here. And this is what we're looking for. But they wanted to know what are the coordinates for W prime, X prime, Y prime, and Z prime. So I needed all of these. This is all of my new coordinates right here. So this one I did have to draw it out. Kind of hard to do because it was so dark, but you can probably see it better on your own paper when you draw it out. All right, number 22. This is the 3-dimensional shapes thing that we've been doing. You're looking at which can be represented by the left view. So we're looking at this part right here. So I've got 1, 2, 3, 4. So we have a 2 by 2, but then we have another part here, 1, 2, 3. So it's, if I were just to draw that side view, it's going to look, yeah, something like that. Because this was my 1, 2, 3, 4, and then 1, 2, 3 is the 1, 2, 3 there. So that's what I'm looking for. So looking at it, it's the choice A. So that's another way to think about doing it, is actually draw out what the side view is and then match it to what you have. So they're asking again for the left, the left view or the side view, whichever I'm doing. Then number 23, it says to select all the 3D figures that have the top view below. On this one, again, I just sort of counted. I have 1, 2, 3, 4 going across, and then I have 2 making an L shape. So I have 1, 2, 3, 4, 1, 2. This one works. And then the same thing here, 1, 2, 3, 4, and 1 there. And so that one works. This one makes like a T, so that's out. And then this one was just straight across, if I remember correctly. So I think that's out. Oh, no, sorry, it wasn't just straight across. It made a kind of an off-kilter T, but that's still out. Doesn't work. All right, number 24, it says which 3D figure matches the top, front, and right views that are shown. So I need to, and it actually happened to be the very first one I looked at. But again, don't always just stop at that. You want to make sure that you are checking all of them. I was just trying to go quickly to get this done for you. So the top view, we're looking at an L shape. So this is my top, 1, 2, and this down here, and this here. So it's like the 3 here, and then the 1 here. This is the 1 here. Okay, I'll kind of put a little X, that there and that there. Then our side view is right here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's my side view. And then my front view is this U kind of shape like this, which is just like this. So A does work for that one. This one tells me to identify the model that's represented by the bottom. Remember that the bottom is the same as the top. So it really, if you want to say bottom or top, it doesn't matter. But again, this is sort of like a stair step thing. So C almost looks right, but it has too many things in it. It has 4, then 3, then 2. This is 3, then 2, then 2, then 1. So C's out a little bit, but this one does work. This one has the 4, and then the 3, and then the 1. And that's what my picture was up here. 4. Oh, wait a minute. I think I did that one wrong. No, that is right. I was looking at it wrong. So we have, again, that was the 3 here. You have 1, 2, 3. And then when I look at this, here's my 1, 2, 3. 1, 2, 3. And then I have 2 and 2. And that was what I had right here of 2 and 2. And then I have 1 there. And that's my one that's left right here. So yes, that was correct. Thought that was right the first time I did it. All right, so I hope that you're studying hard. Make sure that you have all your IXLs done also, so you can get plus 10. And remember, if you have any questions, make sure you email or ask when you can. Have a great evening.